Hello guys, and welcome to another class of IGCSE Mathematics 0580. We are in topic 4, sequences. We're talking about sequences in general in this topic. Everything about sequences. In class 5 here we will be talking about cubic sequences and some other types of sequences we'll see now. Now we have, first we'll start with the cubic sequence. We've learned that if the differences in the third row of differences is the same, then we have a cubic sequence. So that is very quick revision. If the differences are the same in the first row of differences, we have an arithmetic sequence. If they are the same, the differences are the same in the second row of differences, we have a quadratic. In the third row, we have a cubic. But if the differences are not the same in either one, it could be either geometric or maybe a compound sequence. So if a sequence is a cubic, same difference in third row, then to find an expression for the nth term, compare to the cube numbers. There are ways to find the nth term, but in O-level, the cubic sequence that would be given in a question would be easily compared to the cube numbers here. These cube numbers have an nth expression of n cubed. They are just every term is the rank of it cubed, so it's just n cubed. So for example, if you have, let's say 2, 16, 54, 128, and 250, and 432, for example, and you want to find the nth term. Or if you want to find the, for example, 20th term. To find the 20th term, you would also have to find the nth term, then to find the 20th term from it. The way it is, first, before we move on, this sequence, we know now it is a cubic because we are in the lesson, but actually you have to check addition, plus 14, this is not plus 14. So we have not arithmetic, geometric, times 8, this is not times 8. Go to quadratic, we'll have to find the differences. 14, 16 to 54, we have 34, 38. 128 minus 54 is 124, 74. 250 minus 128 is 122. And here we have 50 and 132, so 182. I know big numbers, could use the calculator. And now we have 14 to 38, we have 28 is added. Is that correct? Why I mess up these things here? 216, 54, 128, 250, 432, correct. 2 to 16 is 14, we add 14, we add 40, 38 is correct. 14 to 38, we're adding 24. Thank you if you have fixed this up by yourself. 24. And then we have here 38 to 74. We have a 12 and a 24. That is 36. That is 48 right here. And that is 60. The difference is correct? Yes. And then we'll find other differences, third row differences, 12, 12, 12. We'll have to use this, we'll have to do this in order to find out the type of a sequence we have. And now we've decided that we have a cubic sequence. One thing that could be also useful, the nth term of a cubic sequence must be in this form. Plus Cn plus D, which is the general form of a cubic expression. So we will have to find A, B, C, and D, different ways to find them, but I just wanted to give you what A is equal to, just A. A is equal to the common difference, expect divided by what? By 6. So A right here is equal to 12 over 6, which is 2. So we know that we have 2n cubed plus bn squared plus cn. You could use it the way we've learned in the previous lesson. You could just find 2n cubed and subtract to get a quadratic sequence and find the nth term of the quadratic sequence. That would be a longer procedure. It's not really needed in O level. But this is good to know here, because you want now to compare 2, 1, 8, 27, 64, 125, and so on. Compare our sequence. You'll find this 2, 16, 54, 128, 250. Our sequence. And now you could just notice that our sequence is formed by just multiplying each term of the cubic sequence of the cubic numbers by 2. So you just notice that this is only 2 times n cubed plus that's 0, nothing. It's just 2n cubed. So the nth term is 2n cubed. Let's check. Take 2 for example. 2 cubed is 8 times 2 is 16, and so on. So that's the way in general in O level you just compare to the cube numbers. Okay. Now we may have, this is a rule right here. The rule states that if, for example, the nth term of a sequence is given to you in the question, and then we have removed one of the terms from the beginning of the sequence, we just deleted it, or we deleted 2 terms from the beginning, or we have added on a term in front of the sequence, or 2 terms, or 3 terms, putting on terms in the front here, I mean to the left of the sequence at the beginning, or removed here, that would just change n in the expression. I'm going to show you what I mean by this here. Let's say we have this here, and we know that these are the cube numbers, and we know that this is n cubed. That's the nth term of these cube numbers. If, let's say, we remove the 1, and we get 8, 27, 64, 125, one value is removed, all you have to do is you just add 1 to n in the expression. Instead of n, we'll have n plus 1 cubed. The reason is because when we have n equals 1, you'll add 1 to it first. So you have 2, then you cube. Every time you add 1 to n, and then you cube the answer for the second term. 2 plus 1 is 3. 3 cubed is 27. Now if we take 2 values, we took out 2 values from this is the original one, this is our basic one. So you'll have n plus 2 cubed, and if you remove 3 values it becomes n plus 3. What about if we put on a value in front of it? This 0 is n, which is 1 minus 1, then you cube. N equals 2 right here. Minus 1, you get 1, then you cube. So this is n minus 1 cubed. So let me put it this way. If you have the nth term of a sequence given, and one term is deleted from the beginning of the sequence, you replace n in the nth expression by n plus 1. If you add on a value, you replace n by n minus 1. If you add on 2 values, you will replace n by n plus n minus 2, and so on. I will give you a tricky question here. But before that, let me just give you, because these are very frequently given in the questions, in the externals, which is the square numbers also. So if you have 1, 4, 9, 16, 25, that is n squared. But if you have 0, 1, 4, 9, 16, then you'll have n minus 1 squared. And if you have 4, the square numbers, but starting from 4 instead of 1, 16, 25, 36, that is n plus 1 squared. If you have 9, 16, 25, 36, 49, that is 2 of these terms are removed, so you'll have n plus 2 all squared. When you remove a value, you add 1 to n. This is very frequent question, or very frequent sequences we'll see in the externals. I said, if you, for example, also, if I tell you that A, B, C, D are terms on a sequence, or in a sequence, or of a sequence, with nth term, let's say n times n minus 4, where A, B, C, and D are constants. Let's say these are just numbers, and their nth term is n times n minus 4, for example. Find the nth term of B, C, D, and so on. See, this equation seems to be very difficult if you haven't known this rule. I would say no student can find the nth term of such a sequence if he hasn't known this rule, which depends on noticing that one term is removed or one term is put on. So if you just notice that this is the same sequence, but A is removed, the first term is removed. So what would you do when you remove a term? You just replace every n by n plus 1. So it would become n answer, n plus 1, instead of this n right here. Let me just fix it up. N plus 1, that's for this n right here, times for this n, n plus 1, and then we have minus 4. And you could just simplify if you want to, n plus 1 times n minus 3. So you add 1 to n, you add 1 to n, and this will be the answer. This is interesting question that could be tricky. You may see something like this. Let's see some examples. On finding, we have an example where we have to find the nth term of each of these sequences. This is just the n cubed, because this is the cube numbers, but make sure they start at 1. If they start with a 0, it won't be n cubed anymore. It will be n minus 1 cubed. And as this one here, the same as the cube numbers, but it started from 8, so 1 is removed. So we would say that is n plus 1. We just replace n by n plus 1 cubed. For this one here, we check these differences and so on. You may notice that these are just double of these right here, especially if they come in the same equation. So that is 2n cubed. This one right here, one is added to each value of the cube. So I just compare these after I found out they're cubic. We're just cutting out time here. But we know that these are cubic, but in the exams you'll have to check the type of a sequence we have by finding differences, and you'll find the third row of differences to be the same for all of these. So you know that they're all cubic, and then you would compare to these numbers, and you would notice that this is just one more each term. So this is n cubed, just add one different term right here. They're not the same. Here you have to add 1 to n first, and then you cube. This is n. 1, 2, 3, 4, 5. You add 1, you get 2, then you cube. 2 plus 1, then you cube. 3 plus 1, cubed. N plus 1, cubed. Right here. 1, 8, 27. So it is just 1 cubed plus 1. 2 cubed plus 1. 3 cubed plus 1. N cubed plus 1. So that would be it. And this is it for cube sequences, which would be easy, I believe, for you. And you won't get very complicated ones of these here. They're not really complicated. Now I have a question for you. You know it would be cubic because this is our lesson. But please do the check first. Check whether it is a cubic by finding the rows of differences, and then use that the sixth of the difference in the third row is the coefficient of any cubed, and then compare to the cube numbers. Find the answer within the 4 given answers, give your answer, pick the correct answer, and I hope that you have understood this. We'll see you in another video. Thank you so much for watching, and I appreciate this. Thank you.